This last problem that I'll show an example of from 9.3 and is an example of de Moivre's theorem. And if you remember de Moivre's theorem, it says that if you took RCIS of an angle and raised it to the nth power, then it's as simple as taking r to that power, r to the n power, and the cosine and sine of n times theta. And so that's what we're going to do here. It's a pretty simple application. If we're going to raise this to the fourth power, de Moivre's theorem tells us to take the root 2 to the 4, and then take the CIS, and it was 5 pi over 16, but now we're going to multiply that by 4. So root 2 to the fourth power would be 4, right? Coming out of that. It'd be root 2 times root 2, which is 2. And then root 2 times root 2, which is 2, and those two 2's hitting together before would be one explanation of it. And then we're going to take CIS of 5 pi over 4. Now, they don't want us to stop there. They're asking us to put it in a plus bi form, but if they didn't care what form it is, it's currently in polar form. So we're really good. So now we have 4 CIS of 5 pi over 4. Sorry, I was just going to write the same thing, but that's not a good use of your time. So what we have is 4 times the cosine of 5 pi over 4 plus I sine of 5 pi over 4. And now we're earlier in this section just converting that. So that's 4. Now the cosine of 5 pi over 4, that's going to be a root 2 over 2, but that's a third quadrant angle, so it's negative. And sine's going to be the exact same value. It's a third quadrant angle, and sine's negative there as well, and also root 2 over 2. And so what's the end answer? If we distribute that 4, we get negative 2 root 2 plus, not plus, let me get rid of that plus, minus 2 root 2i. And that's our end result. So that's coming from distributing the 4 through, and the 4's and the bottom 2's are going to cancel to produce a 2, and those root 2's just get attached with an I in that second position. So that is the rectangular form of that complex number.